So starting from the light section, the very first thing that we need to discuss about the light is light travels in the in the form of wave, right? Actually, if we consider the light, so the nature of the light is particle nature plus wave nature. It means light has dual nature, right? It also act like the particles, it also act like the wave, right? But in this particular section we are only going to discuss about the wave form of the light. Okay, so we are
Okay.
only interested in the wave form of the wave, sorry, light. So that's why we only discuss about the wave nature of light. Particle nature will be included in your A levels, so that was the advanced topic. But this time we are only going to talk about the wave nature of the light. And the very first thing, the nature of the light, because it is a type of wave, so we need to categorize this light into longitudinal or transverse. So light is a longitudinal wave or a transverse wave. So light is transverse in nature, right?
Right.
And the speed of light that we already discussed, it is equals to 3 into 10 to the power 8 meter per second. And in light we also going to be discuss the concept of refraction and diffraction. And light does not require any medium to travel, just like the sound wave, because it requires medium to travel, whereas light wave does not require any medium to travel. So these are some journal properties related to the light, because in MCQs sometimes they ask you to underline the features or underline the properties of the light wave. So these are some properties, these are some features for the light. The very first important thing that we need to discuss in the light, that is law of reflection. You already know about the law of reflection because we discussed this concept in journal properties of wave. Whenever light strikes any reflecting surface, like any solid object or any solid reflecting surface, so it will
Yes.
reflect back with the same angle, right?
Yes.
So let's suppose if there is any reflecting surface in the path of light, and light ray is going to be hit that surface with certain angle. Okay, now in this chapter, we are going to discuss about the detailed formation of the rays. So first of all, we need to know about that to measure the angle, we need a normal line. Okay, this will be our normal line. So this line is called as normal, and this line will help you to measure the angle for incident ray and reflected ray. So always measure angle with the reference of this normal line. So when light is traveling from left hand side, so this will be the direction of light, and this is the angle of incidence. Angle of incidence. And when
Mhm.
this light reflects back, so it will reflect back with the same angle from the normal. Okay. This will move in the same direction like this. So it will reflect back with the same angle in the other direction. This will be known as angle of reflection, reflection, sorry. And this will be the direction of wave in the backward direction. So in this way, we easily measure the angle for the incident ray and for the reflected ray. And this angle is known as the angle of reflection. And this one is known as the angle of incidence. And if we talk about these rays, so there is also a term related to these rays, and these rays are known as the incident ray. And the second one is known as reflected ray. So this is the concept of incident ray, reflected ray, angle of incidence, angle of reflection, right?
Yeah, but can you write down the law of reflection? I
Yes,
know it, but I just want to write it down again.
yes. So you also need to write down the law of reflection because there are two postulates also. So according to law of reflection, there are two postulates of law. The first one is the angle of incidence will be equal to angle of reflection will be equal to angle of reflection. And the second postulate is the incident reflected and the norm all lies on the same plane. And the of the second postulate is we just consider the first diagram, and in the first diagram we observe that all rays are on x and y axis or in between x and y axis, right? We are talking with the reference of 2D diagram, right? So they are saying that if the incident ray is on x or y axis or x or y plane, and so if your reflected ray and your normal ray must be on the same plane, right? It will not be on like z axis or zy plane or xz plane, right? So same planes means they are in the same pattern or on the same axis. Okay, so that is the meaning of the second postulate, right? Any confusion?
No, sir.
Okay. So this is very basic because we already discussed that and we already studied this concept in our previous classes. The next thing is where we observe this reflection, we observe a reflection in our daily life in mirrors, right? Because from solid object, let's suppose if in our room a lamp or a light bulb is bright over there, so light is completely reflecting from the wall of the room, and light will reach at every point in the room, right? Due to reflection. But if we talk about a plane mirror, because plane mirror is a very important application of our daily life, so we need to know about the plane mirror, that what is the nature of the image and how to identify the image in a plane mirror, right? So let's suppose if we talk about the plane mirror, so next concept is related to reflection in plane mirror. So again, we use the same concept for plane mirror. When object is placed in front of a mirror, an image of the object can be seen in the mirror, right? So there are some important properties that you need to remember because that will help you in MCQs. Because in this chapter, we are going to talk about different types of mirror plus different type of lenses. So the property of the image in plane mirror will be The first one is, you know that the size of the image will be equal to the size of object. So it means that the size of the image will be same as the object. Next point.
Like the reflected object will be the same.
Yes, the same distance, because when we discuss about the image formation, so there is one important point for the image formation, that is the second point. The same distance behind the mirror as the distance of the object is in front of it. So I will explain this second point in detail with the help of ray diagram, because that is related to the ray diagram. And the third point, directly in the line with the object. So these are three important points. Now let's consider the image diagram, ray diagram, plane mirror. So let's suppose if we are having a plane mirror, and object is placed on left hand side, this. So we consider, let's suppose two rays that is coming out from the object, that is reflecting from the object. So we consider, let's suppose one ray is moving at some specific angle in this direction, and the other one is going to be reflect at some different angle, let's suppose at this. Okay, so we consider two reflecting waves, right? Or we can say that, let's suppose if we consider one incident ray, so this will be incident ray. So it will reflect back with the same angle, right? Again, the concept of normal. So we just draw a reflected ray with the same angle. Let's consider that one with a different color. So this will be reflected ray, right? And same goes for the second one. Okay, so the purple one are the reflected rays and the green ones are the incident ray, right? Now, for ray diagram in plane mirror cases, and in the center we are having in mirror. And you know, in plane mirror, one side is completely shined, the reflected one, and the other side is the rough one, right? So right side is the rough one and the left side is the reflecting one, with the shiny surface. Now in the ray diagram of mirror, always remember we never draw the image on left hand side or on the same side, right? What we do, we draw the point, or we draw the mark of the image on the other side of the mirror, just for the theoretical purpose, right? Not in the real life. We know that in real life image will not form behind the mirror, right? It will always in front of mirror. But for simplicity, for a clear uh, identification, we just mark image on the right hand side, because on left hand side there are multiple waves, and if we mark image on the same side, so there will be confusion and there will be intersection, right? And we know that rays will never intersect in reflection or in refraction, right? So what we need to do, we actually need to draw a line on the back side of the mirror, just a virtual line like this. I am marking the dotted one. Okay. So on left hand side, we are having our object. On right hand side, we are having image, right? Now, if you want to find out the angle, so this angle will also be equal to the angle on the right hand side. So angle remains same. Okay. Any confusion?
No, sir.
So just for the ray diagram, we always mark image on the other side, right? But we know that naturally image will always form on the mirror. So that's the second point, the same distance behind the mirror as the object is in the front of it. So you need to take the same distance and mark the point on the other side for the image. Like it will be in a straight line or in the line of object. If you measure the line, so this will be in the same line, right? So
Right.
image will be in the same line. So you just take the same line, same distance on the other side, and then just mark your angle. And it will also follow for the second line or the second ray. So this is the concept of the reflection in the plane mirror, because most of the MCQs ask about the image formation for plane mirror, that where will be the image form. So students, what mostly do, they just take the reflecting angle and they just mark that image will form at this point. So that is not right, because according to the rule, according to the law of reflection in plane mirror, we need to mark image on the other side. Okay, just for ray diagram. So that is the important concept for plane mirror. Okay. And you observe that we draw dotted line on right hand side and regular lines on left hand side. So this dotted line shows you, this line is known as the virtual ray, because it is not normal, or it is not natural. It is only drawn for the theoretical purpose, for the observation purpose. So that's why it is known as the virtual ray, right? And these are the incident and the reflected ray, right? And for more clarification of the virtual ray, we can say that it cannot, right? So these type of rays cannot be obtained on the screen. We know that it is just behind the mirror. So that's why it is known as the virtual. This is only for the identification of the reflection of ray on the other side of the mirror. So that's why it is known as the virtual image or the virtual ray. Okay. Any confusion?
No, sir.
Okay. So from law of reflection, we observe that angle of incidence will always equals to the angle of reflection, and all lines are going to be on a same plane, right? So that is the basic concept of reflection and reflection in plane mirrors, right? So these concepts are very much simple and very much basic, because it is only related to reflection, and reflection is the most simplest phenomena among all refraction and diffraction. So your second concept is related to refraction. Refraction is a detailed one, because there are many different possibilities for refraction of medium, because One more thing for reflection, if you want to write, that we can say that reflection shows you the bounce back of light rays, right?
Right.
Bouncing back of light rays. One more important thing, in the same medium. Same medium means light is traveling from air, it will reflect back again into the air, right? It is not going to pass through the reflecting surface. So medium will remain same for reflection, because it is very important difference between reflection and refraction, because when we are going to talk about the refraction process, so let's suppose if we want to start for the refraction, so in refraction it is very important to know about the medium, because refraction in simple words we can say that it is the bending of light waves, bending of light rays when light travels from one medium to another. So in refraction, it is very important to move light from one medium to the other medium. So there is a change of medium, right? So it means that just like the reflection, light will not reflect back into the same medium. There will be a change of medium definitely, right? So in this concept, now we are having angle of incidence and the angle of refraction, right? So let's suppose
Right.
if we consider two different mediums. And if you observe this application in our daily life, let's suppose if we are having a water, if we are having a glass filled with half water, so when we place pencil, pen, or a straw in it, so you observe that that straw or pencil will be observed in different direction, right? Because of change of medium. Just like the light in the swimming pool, uh, we observe object under the water in different position as compared to the object placed over the surface of the water, right? That is because of refraction. So let's suppose if we are having a change of medium, so we need to draw a normal line first. So this will be our normal line. So the medium above the surface is the air, and the bottom surface is known as, or the medium under this surface is equals to the water. So we are having two different surface. Let's suppose light is going to be enter into the swimming pool, so from air light is going to be travel into the water. So let's suppose we are having our incident ray coming from the left hand side at certain angle like this. So from where we need to measure angle of incidence, from yellow line or from white line? If we need to mark angle of incidence, so from which line we need to take the reference, from the yellow line or from the white line? Where will be our angle of incidence? This will be angle of incidence, right? With the normal. And when light travels from air medium to the water medium, it will be like this. The final formation of the light will be in this direction, right? And now if you want to measure the angle, so this will be your angle of refraction. Okay. Now if we mark the points, so this will be refracted ray, and the purple will be incident ray. And remaining colors will be angle of incidence, angle of refraction. Okay, any confusion?
No, sir.
Okay, now one important thing that you observe when light travels from air to the water, so light actually bends towards the normal, right? Because the angle of refraction is the shorter as compared to the angle of incidence, right? So you always needs to remember that. I will write two important points over here that you need to remember, because that will help you to make the ray diagram. Let's suppose if there are two medium given and they ask you to draw the ray diagram just like the same. So we need to know that in which direction light will bend, right? Because we don't know in which direction we need to draw the bending, because I will also draw this refracted line in the upward direction, but I only draw in downward direction. So there is a reason, and the reason is that, let's suppose if we talk about the first point. So when light travels from rare medium to the dense medium, medium means, if we are comparing two medium, let's suppose air and water. So air is the light medium, rare medium, and water is the heavy medium, that is dense medium, right? So when light travels from rare medium to the dense medium, let's suppose if we compare glass and water, so water is rare, glass is dense as compared to water. So that's why I used to write rare and dense, because it is not compulsory that light will always move from air to water. Medium may be any medium, right? So we need to know with the reference of rare and dense. So when light travels from a rare medium to the dense medium, it will bend towards the normal. Okay, just like the diagram we draw over here. I am writing here that with the reference of diagram. This statement is for the rare medium to the dense medium. And let's suppose when light travels from dense medium to the rare medium, it will bend away from the normal. Okay, clear?
Yes, so it bends away from the normal medium.
Yes,
No?
it
Okay.
yes, from the normal. So normal means this line. If you compare this yellow line, so the orange line, that is the refracted ray, it is close to the yellow line. So it means the purple line is at greater angle from normal, but the orange line is close to the yellow. It means towards the normal. And if you just invert your screen, so you will find a second point. If we just invert our screen, so yellow line, oh sorry, orange line is close to the medium, that is water. So water is the dense medium, right? And when it is passed into the air, so it will move away from the normal with the greater angle, right? So if you invert your screen, you will find the second point. And if you observe your normal screen, so you will observe that light is moving from air to water. Okay, just like this. If we observe like this, right? So now you can see that orange line is coming from the water and moving into the air, right? So now you can see that the angle with the water in the water medium is small, but the angle in air medium is greater. It means that purple line is moving away from the normal, right? That's why angle is greater. Okay, clear?
Yes, there.
So this is very important concept because in exams they ask you to draw the incomplete diagram. So you need to know that in which direction we need to draw a ray, because we know that we need to draw in other medium, but in which direction, because that is also important, because that will give you the final picture of the ray diagram. So it is very important to know about that in which direction the ray is going to be bent or ray is going to be refract. So when moving from a rare medium to the dense medium, it will bend towards the normal. And when from dense to rare medium, it will bend away from the normal. Okay. So this is the concept of refraction of light. And we will use to discuss rare mediums like air only. And for dense, we used to discuss water and glass, right? Because glass is also a dense medium. It is more dense than the water. Okay. And why this light actually bends in it, so we can write this point as the change in direction. It occurs to change in speed, traveling in different medium, right?
Yes.
So when light travels from one medium to the other one, so its speed will also change because it needs to now cover more distance because of that greater angle or shorter angle. So speed will change, because let's suppose if we are moving in a straight line, so that is the shortest path. And if we are moving in random directions, so it will take time. So our speed will increase or decrease as compared to the original case. So that is the concept for change in direction. And it does not change color. Color will remain same. Okay.
Oh,
So during refraction, color will not change. That will only change in prism diagram. So when we discuss about the prism, so then we will discuss about that concept. Okay.